Hello friend, today we have another question and it is important question. First we will try to understand the question first, then we will discuss about the approaches, then finally I will solve the question in the GFG compiler. Okay, the question says that a stock buy and sell maximum one transaction allowed means stock price is given. You have to allow only one transaction and you have to find the maximum. Okay, this is easy level question, but when this question move into a stock and buy, a stock buy and sell problem, maximum two transaction is allowed. That question become hard level. So that's why I am discussing first one transaction allowed, then I will discuss two transaction allowed, then k number of transaction allowed to find the maximum. So first I will solve the easy one, then hard level also. So this question is very important to solve the question. Stock buy and sell maximum two transaction allowed. Okay. So first try to understand this question. Given an array prices of non-negative integers, okay, means prices is given in positive. Okay, then representing the prices of the stocks on different days. Means they are representing the price of the stock of different days. The task is to find the maximum profit possible by buying and selling the stock on different days when at most one transaction is allowed. Okay, we have to find the maximum profit possible by buying and selling the stocks on different days. At most one transaction is allowed. Only one transaction is allowed. Okay. Here one transaction means one buy plus one sell. If it is not possible to make a profit, then return zero. Okay. So in case in case we are or I am not able to find the profit, then in that case I have to return zero. Note, a stock must be bought before being sold. Means first we have to uh, buy the stock, then we have to sell the stock. Okay, here it is given. Suppose suppose I bought at price 1 and sell at 9. So maximum profit is 8 rupees. Okay, so we will do the dry run first here. Hmm. Okay, so here maximum transaction is allowed equal to k equal to 1. Okay, so here price of the array is given. This one, buy and sell. Here. Okay, so suppose we have to buy here, sell here, buy here, sell here. Buying price this one, selling price. In this way, we can find like here 7, 10, 1, 3, 6, 9, and 2. Suppose this is my buying price, this is selling 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 price, and we have to maintain max. Again, this one is buying price. I is here. I is here. J is here. Difference. This is buying price. 10 rupees is buying price. Selling price is 1, 3, 6, 9, 2. We have to find the maximum. Again, this one is buying price. And this is selling price. 3, 6, 9, 2. Again, this one. So, what is the time complexity of this program? Will give TC of big of n square. Hmm, okay. Or here, suppose here, this is my buying price. Okay. And here, suppose this is selling price. Or we have to find the maximum. So we have to maintain one thing. Like one is minimum. If we keep minimum here, okay, minimum. So we have to find from minimum, and this one is your selling price. Suppose here minimum is this one, minimum 7. Here I equal to here, and selling price is 7. So maximum max equal to max equal to selling price 7 minus minimum 7, 0. Then here update minimum. 7 is greater than 10. No. So here 10 is selling price. Then 10 minus of 7, 3. Update maximum 3. Then here update minimum. 7 is greater than 1. Yes, 1. Then 1 minus 1 equal to 0. Selling price and buying price same. 3. Update minimum. Minimum is greater than 3. No. So what will be the answer? Max. Or T1. And T1 is 3 is the selling price and buying price is 1. 3 minus 1. 2. Maximum is 3 is smaller than 2. No. Then 6. We are finding the minimum from here and storing the variable into mean. And here we are finding this is a selling price. So selling price means selling price minus buying price. Buying price is minimum. Okay. Here 6. Then T1 6 minus minimum price 1 5. Maximum 3 is smaller than 5. Yes, update 5. Then come to 9. Minimum 1 is greater than 9. No. Then again find T1. 9 minus 9 is selling price. 1 is 5. Minimum is buying price 8. Then max is smaller than 8. Yes, update. Here 2. So 1 is smaller than 2. No. Here minimum 1 is greater than 2. No, no. Then in that case here come here. Then selling price is 2 and buying price is minimum 1 equal to 1. Update 8. 8 is smaller than 1. No. So what may answer? 8 here. And time complexity of this one bigger of n. This is also solution. First I will write this solution, but this solution is only uh, mm, good for minimum number of transactions is 1. But suppose in case of minimum transaction of 2, so that will not work because we are checking each and everything from here to here. Buy, sell. If one transaction is allowed, it is fine. But for two transactions, you have to find it. So that is a general, and I will discuss if two transactions get three transactions, four transaction is given. So you can easily write the program for n transaction. For one transaction, this approach is clear. You have to find the minimum from here, and suppose here this is selling price and update the maximum. First, I will write this approach. Hmm. Okay. We have to find the maximum. Teaser dot value. Then if int min equal to integer dot max value or int I equal to 0, I less than prices, or we can say array dot length I plus plus. First we will check if minimum is greater than array of I, update min to array of I. Then next find T1 means this is selling price. Selling price is array of I, and find minimum is that is the buying price. Buying price is means if max is smaller than T1, update max T1. Over again it will check for each and every, and last we are returning maximum profit. We have to figure it out. Correct. But this approach is good for mean one transaction is allowed. In that case, this approach will work. But in case of two transaction, three transaction, four transaction, it is not good. So we will convert this program into a general form like get number of transaction. How? First, hmm, okay. Then suppose k number of transaction is k equal to 1 is given. So how you can solve? Okay, here you can make 2D array. Put all the values 7, 10, 1, 3, 6, 9, 2. Here, then suppose zero transaction, no transaction happen. So all are zero. Suppose only here only one transaction is here only one transaction allowed, and here only one element, then zero. Buy at 7, sell at 7, 0. So here we have to find in one transaction happen, that will be the maximum 0. This one, or here zero transaction is completed, and we are looking for one transaction. Okay, this one 0, zero transaction this value, and for one transaction 10 minus 7, this one 3. Which one is maximum? 0 and 3. 3 is here. Suppose one transaction we got maximum value 3, and here zero transaction is happen, and this is one transaction, 1 minus 10. So 0 plus 1 minus 10 is one transaction. Or here zero transaction is happen, and one transaction is this one, 0 plus 1 minus 7. So here we will get maximum 3 minus 9, 7 minus 6. Which one is maximum? 3. Here 1, 3, and this one. Zero transaction happen, one transaction. On this zero, zero transaction is happen, so 0. Then here, one transaction, 3 minus 10. For here, we will get the answer maximum of all. So here 0 plus 3 minus 1. Then here 0 plus 3 minus 10. Here 0 plus 3 minus 7. Which one is maximum? This one. 3 minus 1, 2, minus 8, 3 minus 7, minus 4. Which one maximum? 3. here zero transaction happen, this one transaction, then mm, 0 plus first one is 3, then 0 plus this one 6 minus 3, then from this one 0 plus 6 minus 1, then this one 0 plus 6 minus 10, then here 6 minus 0 plus 6 minus 7, which one is maximum? 3, 6 minus 3, 3, 6 minus 1, 5, 6 minus 10, minus 4, 6 minus 7, minus 1, which one is maximum? 5, 5 is maximum. Here 0 transaction and 6 minus 3, how much? So first we have to find the maximum, 5, then 0 plus this one 0 plus 9 minus 6, here 0 plus 9 minus 3, here 0 plus 9 minus 5, 9 minus 1, 0 plus 0 plus 0 plus 9 minus 10, 0 plus 9 minus 7, which one is maximum? 9 minus 3, 6, 9 minus 6, 3, 9 minus 1, 8, 9 minus 10 minus 1, 9 minus 7 equal to 2. Which one maximum? 8. 8 is the answer. So, buying at this price, selling at this price, so maximum. Here you can find. Okay. So, max equal to 8. And here 0 transaction is happen. So, amount for 0 transaction 0 plus 2 minus 2 minus 9, then 0 plus 2 minus 6, 0 plus 2 minus 3, and 0 plus 0 plus 2 minus 2 minus 1, then 0 plus 2 minus 2 minus 10, and 0 plus 2 minus 7. What value? 2 minus 9 minus 7, 2 minus 5 minus 3, 2 minus 3 minus 1, 2 minus 1 1, 2 minus 10 minus 8, 2 minus 7 minus 5, and 8. Which one is maximum? 8. Or here we are checking maximum, or you can say like that 2 is common for each and every, or we can say 2 minus 9 plus 2. So 0 minus 2 plus 2, 0 minus 9 plus 2, we can say 0 minus 5 plus 2. So we are finding maximum. So from here, suppose this is a constant, and here which is the maximum, we will store into the max value and add plus 2. So from here, so for this approach, one is k number of loops we will run. Okay, and suppose k equal to 3, k equal to 2, k equal to 3 in this way. So k number of loops. Then for here we will check again and again. So k into n square. So we have to reduce the time complexity. So how? That's why we are creating one max variable, and finding all from here. Let's start from here. Then it will check 0 minus 0 minus 7. What is the maximum value? This one. From here 0 minus 10, find the maximum value. Then check here, and uh, first this one will check. Then next time for here this one 0 minus 10, and maximum smaller than 0 minus 10, update the maximum. And for add this one, so will that will give the maximum value from here to here adding. And this one, which one is maximum, that value will this one. For here we can check 0 minus 1, maximum is smaller than 0 minus 1, update the maximum, and another value is this one, and add, because from here it is taking a value, maximum value. Okay, and the maximum value plus this one, because this is from a 0 plus 2 minus 9, 2, the selling price is 2, 2 is common, minus 9, that's why 0 minus 9 we can write. So we can find it first for maximum plus 2. So in this way we can find it. Okay, so first here 0 minus 10, 0 minus 1, 0 minus 3, 0 minus 6, 0 minus 9, 0 minus 2 we have to find and update into and update the maximum. And here what will value? Here for here we are finding this one, this, and this one. Whichever which amount, which value is maximum, that will put here. Here same thing. That's why we are creating one max, and that will update always 0 minus 7, maximum is smaller than, so update the maximum. Here 0 minus 10, update the maximum. So for here we have calculated all the three, which one is maximum, plus this amount, we will got it. So in this way we will solve this question, and with the help of this approach we can solve two number of transactions, three number of transactions, four number, n number of transaction is allowed. Okay, so this approach is very important. I hope you can understand. First I will create DP array. Continue. In first one is k equal to 1. So 2, k equal to 1 is allowed, k plus 1, 2, 0, 1, and here I will put array document. First one all are zeros. Okay, then we will start from this point. So 4 in 4 in I equal to hmm, hmm, I equal to 1, I is less than dp dot then I plus plus. Okay, and j will start from 1, j equal to 1, j is less than dp of 0 dot length, and j plus plus. This is general for in case two transaction is allowed, three transaction is allowed, so you can solve in this way. Okay, and for every time maximum, we have to find the maximum. So here in max equal to integer dot min value. So if max is smaller than, which one, max is smaller than dp of I minus 1 and j minus 1 plus array array of array of j minus j minus 1. Okay, hmm, hmm. This one, this value here, this one dp of I minus 1 j, j minus 1 to this one, and here the dp of j is here j minus 1. If it is smaller, then update math equal to dp of I minus 1 j minus 1 plus array of j minus 1. Then fill uh, fill here dp of I and j equal to math dot math dp of this one dp of I no, j minus 1. Yes, it, it is clear before first, and here max max plus array of j this one here thing here we are putting here this one here we will put maximum we have find the maximum of here plus this value that because you are constant here same thing. Here 2 is 2 is constant, that's why we can write 0 minus 9 0 minus 5 which one is the maximum plus 2 will give the value. That's why here I put it max plus array of j, and at last this will return dp of dp of 1 comma j array dot length minus 1. This is the answer. Okay. Hmm. Where line number 15. Hmm. Okay. Hmm. Oh, we are getting 13 answer. Why? Max is if max is smaller than dp of I minus 1 j minus 1 plus plus not minus minus of array of j. So that way here we got the formula. Hmm. Here this one 0 minus 9 0 minus 3 okay minus hmm. Then here we can add the value. Hmm. Yes, we got the expected output. Now I am going to submit the code. Hmm. This is a general solution for all number of transactions like 1 transaction, 2 transaction, 3 transaction, 4 transaction, 5 transaction is allowed. So in this way you can solve the problem. Thanks for watching. Bye bye.